Today we talk about the types of matrix. So first we talk about what is the real matrix. Here we see the definition of the real matrix, but also tell you if the all element of the matrix are in real numbers. Okay, means if we have we have a given matrix, so that's example 1 2 3 4. Here we see that all the element of the matrix are in real numbers, no any complex number or anything. So if all the element of the matrix are real numbers, then it is said to be real matrix. And when we talk about complex matrix, as you understand, all the element of a matrix are complex numbers, or either at least one element of the matrix are complex number. Here you see the example. All the entries of the matrix are complex, and here is only 1 3, that is row number element 3 1 is complex, so it is said to be complex matrix. And another matrix is horizontal matrix. So horizontal matrix, a matrix, okay, if a m cross n matrix whose number of rows is less than the number of columns, here is the number of rows is less than the number of columns, this type of matrix is called horizontal matrix. Or when talk about vertical matrix, if all the number of rows is greater than the number of columns, it's said to be vertical matrix. Yes, see some example, and horizontal and vertical. Rectangular, if a matrix m cross, all the matrix m cross n except where number of rows is equal to number of column, which is square. So if number of rows is equal to number of column, it is not rectangular, it is square. So all the matrix of m cross n where number of rows is not equal to number of column, it is only condition, this type of matrix are said to be a rectangular matrix. And here you see, or single element matrix, only one element matrix has only one entry, m1 cross 1, this is square, also rectangular. Suppose this matrix has only one element, so it's said to be single element. And also said m cross and same square matrix also say because of only one item. So this is the single element matrix which has only one element. When we talk about raw matrix, as you see the definition, m cross n matrix whose has only one rows and number of column are unchanged, and that is up to n. This type of matrix are called row matrix or row vector, because it has only one row and columns are unchanged. And the column matrix are when we talk about column matrix, if number of row are a changed value, that is unchanged, but columns have only one value, so it means columns has only one but number of rows are different, and is said to be column matrix. Here some example. And we also denote, because of if we denote this type of position, it take lot of space. So to reduce the lot of space, we also denote this in a curve bracket, and also like a square, like a row matrix, but a small dash on right hand side. It's said to be column matrix. And zero matrix, if all element are zero, is said to be zero matrix. See as definition. Or null matrix, and simply 0 m cross n and mn and 0 order, or simply as 0, or 0 matrix of 2 by 2 order, something m cross n order. And here's some example of this. And let's talk about square matrix. A matrix called square if number of rows is equal to number of column. we know what is the square. Square has the both side, for all four sides are equal, means the number of row equal to number of column, the number of horizontal line equal to the number of vertical line. That's why this is square. So also for matrix, if number of row equal to number of column, then it is said to be square matrix. And where let's talk about the diagonal of a square. The diagonal of a square where I is equal to z, that is which element which has I is number of rows equal to number of z, means I just 1 a11 a1 a22 a33 and a66 this tab are said to be diagonal. If talk about the diagonal, here are some easy way. Since when we talk about a square, so the diagonals, here where the diagonals, then when we put the element on that, the element are which the intersecting rows and columns are matched in the diagonal, the numbers are in which has same rows and same columns, that is a22 two rows, second row second column where intersected, this become a diagonal of a square, and it is also called that's why it's called diagonal of the square matrix, and has all the same rows and columns, and I is equal to z. And the order of, because of square, the number of row equal to number of columns, so we also call n cross n, n square, m cross m. Okay, or let's talk about the conjugate elements. The diagonals act like a mirror, and the above side of the diagonal, that is aij, is the mirror image of lower side of the diagonal aji, and also vice versa. So that's why it's called conjugate element. aij is equal to aji, and also we otherwise say that it is a like a mirror image, and the diagonal elements act like a mirror. So share some example. The diagonal act like a mirror. The a12 here, a21 a3 a13 a31 a23 a32, like a mirror image. Or where all the diagonal element lies, this line is called leading diagonal or principal or main diagonal. Okay, diagonal matrix, a square matrix of m cross m, which is square matrix, said to be diagonal if aij, where I not equal to z, is 0, that is the diagonal above and below all the element are 0 except the diagonal entries are said to be diagonal element, and denoted by diagonal d1 d2 d2 dn if the d1 to dn are the diagonal entries. Some example here we written as this is the matrix of 3 by 3, the diagonal entries are 1 2 3, so I also written a diagonal 1 2 3. Scalar matrix, a diagonal matrix whose all the non-diagonal entries are 0 and the diagonal element are all same, is said to be diagonal is said to be scalar matrix. So in mathematics way we written as IA is a square matrix of aij m cross m. So the A is equal to alpha if I is equal to the, which is diagonal entries, and where I not equal to say is 0. Here's example, that is the all element except diagonal are 0 and the diagonal entries are all same, 3 by 3. This is also diagonal all elements. Okay. I have unit and identity matrix, a square matrix of order n cross n is said a square matrix of order n, or a diagonal matrix of order n, or a scalar matrix, because all the elements are same, if all the element of the diagonals are unity, that is 1, is said to be identity matrix or unity matrix. That is if a is equal to aij is an n cross n matrix, then aij where the diagonal entries are 1 and the I not equal to 0, where the not except all the diagonal except diagonal entries and all the other entries are 0, said to be identity matrix. Here some example. Here is 2 by 2 matrix, diagonal entries are unity and all entries are 0, You'll also see diagonal elements are 1 1 1 and all other elements are 0 0 0. Okay, and also because of diagonal and this 1 1 1 and denoted by in triangular matrix, if square matrix, the above or the below the leading diagonal element are 0 is said to be triangular matrix. If upper entries are 0, then it says to be lower triangular, and if lower is 0, then it's said to be upper triangular. Because why? if upper, let's talk about, हम बात करते हैं कि upper matrix कौन सी upper triangular. So here why we call this a lower triangular matrix. देखो, when all the element of all the entries or element of a diagonal leading diagonal are 0, the only parts where the diagonals are where the entries are non-zero is form a triangular, and which is located at the bottom at lower side, and that's why it's called lower triangular. And when the lower part of the matrix are 0, the leading diagonal above side the elements are non-zero, and that's why matrix are said to be upper triangular matrix. Okay, that is the matrix of m cross n, and this is the leading diagonal, and upper side element as I less than j, because of row is 1 and the column it's also changed, and here is I is greater than j because the row is column is fixed but rows are changed. That's why I cross I less greater than j, here I less than j. For some example, if 1 2 means I is 1 row 2, so clearly I is less than j, and here 2 1, so we see I is 2 and j column is 1, so I is greater than 1. Or you understand, and why we call the lower matrix or lower triangular matrix and upper triangular matrix, because you see, ठीक हो गया. And the strictly, अब बात करते हैं the strictly triangular matrix की. So if the above or below both side of the diagonal entries are 0, upper side and lower side, where I is less than 0 and greater than 0 is 0, then it is said to be strictly triangular matrix. Okay, so here the aij is equal to 0 for every I greater than j, here this, and or I less than j, here this. So 0, then it is said to be strictly triangular matrix. Okay, or let's talk about submatrix. Okay, in a given matrix, if we obtain a matrix from a given matrix, then it is said to be submatrix. For example, we have a square of cake. Okay, we have a cake which is square, and we took another piece of cake which is square, and we from the given cake, so the which piece we take is also the sub matrix. For example, is also the sub of this cake. So here's some example. A given a matrix which obtained from a given matrix by removing any row, column or both, and said to be submatrix. The matrix 3 by 3, we obtain a 2 by 3 matrix from a given matrix by deleting a row number 3, we obtain. So this is submatrix. This is the part of this we remove from this. जैसे हमने स्क्वायर जो केक था उससे हमने छोटा सा पीस निकाला, वो भी स्क्वायर ही था, और वो पीस उसी का था केक का, बट वो उसका सब मैट्रिक्स फॉर्म है, यानी कि उसी से लिया गया है, वो हमने थोड़ा सा हिस्सा रिमूव कर दिया. दैट्स वाई इजी वे. एन इक्वालिटी ऑफ मैट्रिक्स, टू मैट्रिक्स when they are equal, so this are only two condition. So equality of matrices, two matrices are said to be equal if and only if there are two conditions, they have same order. Obviously two arrangement are equal when they look by same, and the all element of their corresponding are also same. Means that we have two arrangement here, some here are footballs on this arrangement and also football this arrangement. If the look wise same, that is order, so also same, and the element of the both side the element are same, then this is also equal matrix. If we have an order same, okay, the arrangement of the order same, and here is order same, but here is the footballs and here is the cricket balls, so the not same, not equal. Okay, if the two matrices are in same order, so this said to be a comparable matrix. Okay, because they are same order. If elements are also, this is also equal matrix. We understand we have a arrangement of matrix which have footballs on the, and also the arrangement of same order, and also football is same, so this are equals, not same other. Okay, okay, or okay, and a matrix are said to condition for to verify the matrix are said as a set. How we say that the set is a equivalence relation function, function relation sets and function. We talk in 12th degree how a relation is equivalence. So so there are three conditions. First they are reflective, A is equal to A, and second is A is equal to B, so B is equal to A, that is symmetry, and third is A is equal to B and B is equal to C, so then A is equal to C, that is transverse. So if the matrix is follow in three rules, then it's said to be equivalence and equal. That is this. And let's talk about the multiplication of a matrix by a scalars. That is simple. So this topic we talk in next class. So I hope you understand. Thank you.